Hey, I'm srcmake, and today we're going to walk through one of Google's problems from their code jam from 2022 round 1A, their first problem called double or one thing. I'm going to talk through the problem really quickly. I'm going to talk about the algorithm that would solve this problem, and then we're going to write a little bit of code. The link to this problem and the GitHub page that has the code that I'm going to be showing you will be below this video. Okay, so let's go through the problem statement. You can pause the video right now if you want to read through this yourself. Otherwise, I'm just going to give you the too long didn't read. Basically, we are going to be given a string. It's going to be all uppercase English letters. And we are allowed to double each individual letter, which means we can duplicate it to be 2 times. So for example, this H here could be doubled. This E could be doubled. This L could be doubled, this one could be doubled, etc. The goal is to find the lexicographical or alphabetical earliest word that we can find. So there's 3 examples here. The first one is the word peel, P-E-E-L. So what we want to do for this is we want to double each one of the E's because this word is the earliest that we could form if we were to try to double every single letter. The key insight to solving this problem is that we only want to double a letter if it is earlier than the letter that follows it. So for example, this P, we would not want to double because we could just keep this E, and E is actually earlier than P is alphabetically. And the other insight, which I'll just tell you now, which is sort of an edge case, is you never want to double the last letter because there's nothing after it to need to, make it be earlier. Okay, so let's go through some code. I've got my template code set up right here. Any Google Code Jam problem, this is basically how you would do it. So you see the input that they give us is only one string named S. In my code, I have string S. We read the input from that. We set up a string for the output. And so if we run this make file, which will compile the code and write something to our output. Okay, so here's the first thing that we want to do. We want to find all the single letters inside of S so that we can have easy comparisons to see really easily, is this letter earlier or later than the letter before it? So for example, peel would turn into pel. A, with all those crazy A's in there, is just going to turn into A. And so what we're going to do is I'm going to paste this in. We are going to get a version of S without doubles. We're going to create an empty string. We're going to go through each character inside of S. The first letter we're just going to add because it's the very first one. For every letter after that, we're going to do a comparison with the previous letter. So if this is equal to the last letter, then it's a double or a triple or whatever. We don't want to add it because it's a duplicate. But if not, it's just a single letter, so just add it. And that S single will turn into something like this. For peel, it's going to be pel. So now we actually have 2 strings that we need to go through. One is the single version of S and one is S itself. So what we need is 2 pointers. So we're going to create 2 pointers. They're going to track the indexes that we're looking at, single index and S index. And what we're going to do is we're going to go through the single index first. So pel we're going to be going through. So we're going to do a comparison. We're going to check if for each letter in S singled, is it bigger than the next one? So for example, this if statement is going to trigger for P-E-L. This if statement is going to trigger for P because P is bigger than E alphabetically. And so what do we want to do? We want to add this P and we don't want to double it. So we've got a while loop here and we're going to add this P and then we're going to increment S index because we're going to check the next index of S. We're going to keep doing that for every letter of P that's available. So for example, if S was P-P-P-E-E-L, we would only want to add each one of these P's 1 time. And so that's basically what this while loop is doing. It's going to add each one time. It's not going to double any of them. Then we're going to move to the next letter inside of S singled, which is going to be this E. That is not bigger than L. It's first alphabetically, so it's going to trigger this else statement. What do we want to do in this scenario? We want to double it because it's going to make our final word alphabetically better. Then, like I said, a little bit of an edge case. For the last letter, we never want to double it. And we just add the last letter the appropriate number of times. And that's it. Let's run our makefile to build a solution. You'll see that our answers match what the Google sample output is. So let's go ahead and copy this. Let's switch to editor mode. I'm going to make this bigger. Let's expand this. I'm going to paste our solution in. We were reading from a file in to do some quick iteration on our computer. I'm going to submit this. We're waiting for this to check whether it's correct or not. And it's correct. This problem has a lot of different edge cases that you want to go through. So actually the sample input probably isn't good enough. We would probably have to make a few more if we were doing this ourselves. The other tricky thing besides edge cases is keeping track of these 2 pointers and making sure you're doing things appropriately. And this while loop actually isn't even that easy. Maybe there's a better way to do this, but I was just writing this really quickly. So that's the problem. If you like this video, please leave a like, leave a comment, and subscribe to the YouTube channel. Thanks.